So, good afternoon, everyone. So, we will start this class within few minutes. Let's see others are joining or not. শুভজিৎ একটু আওয়াজ আসছে ভাই। So, good afternoon. So, is this skin visible? Kindly confirm. Hello, Arjun. Is this skin visible? Is this skin visible? I am saying that whether this skin is visible or not. Okay, okay. So, let us start. So this is the third live session on this course. So in the previous two classes we have discussed about these basics. And so myself Niloy and I am from IIT Bhubaneswar UTA for this course. And in this current week we will discuss about few concepts on this fluid dynamics. So before this, let me introduce about this course. So this course is basically for the students of civil engineering, mechanical, chemical engineering, and even for this interdisciplinary course. So why this course is vital? Whatever phenomena you are observing in daily life, such as wind flowing over a bridge or over a building, even in a floating, something is floating on water, each and everything you observe, there is some fluid mechanics beside this. So this course will help you to solve uh, many real life problem which is essential, such as if you are planning to design any ship or any types of prototype, so you need this concept. So before starting these courses, let me tell you one thing that if someone is interested for this exam, please enroll before this 15th of this month, and I think that this will help you to regain confidence on these courses. So better please go through this curriculum and accordingly follow this thing. So this has been given here. So what we have discussed in the second week is that the first we have discussed about this concept of fluid hydrodynamics. Next about this measurement of pressure and hydrodynamic forces, and we have solved some numericals on this concept. And also on the buoyancy, metacenter, stability, and all these things we have solved few of the questions. I hope that whatever I have shown you in the last classes, that will help you to solve the assignment that has been given in this curriculum. So these are the content that I will discuss today. So the first is this Reynolds Transport Theorem. Next is this momentum conservation of mass or continuity equation, you know. The third is the conservation of momentum. So I hope that all of you has gone through these main courses where Professor Shubhashis has gone through this topic, and in these classes we have I will discuss some numerical on this concept, and I hope that this concept will help you to clarify this real life problem. Okay, so what I will do today is that I will show a question and I will give 1 minute or 2 minutes to you to solve this question. And if you are able to solve this question, please let me know whether this answer is correct or not. It doesn't matter, but try to answer at least. So that will definitely help you. So after you answer you can answer this question in the chat box also, or you can open your mic and answer. So what is the first question? The first question is that which of the following is an intensive property? So these four are the option. So first try to answer, and after that I will explain about this concept of intrinsic and extrinsic property. Uh, so please try to answer this question. So you are saying option B, density. Okay, let's see. Also, Dev has answered option B. So before answering this question, so let me clarify this concept. So what basically is intrinsic property? Intrinsic property means the property which do not depends on the total amount of material. That means it do not depend on total amount of matter. Okay. So if I and for this extensive means it depends on the total amount of matter. So some of these examples is that temperature, you can think of a temperature, pressure, density, and for this extensive the mass and volume, energy, momentum, and all these things are extensive. So say how will you quantify which one is extensive or which one is intrinsic? So to quantify this, so let us assume a condition. So this is a vessel, right? So it has certain amount of water. So in the same vessel, if you increase this, so the amount, let this amount be x. If you increase this amount to 2x, some of its property will definitely change, right? So say if m is the mass of this system, so if I double this quantity, so what will happen? The mass will be twice m. So that means it depends on the total amount of material. So it is extensive. So mass is thus extensive. Similarly, if I talk about density, so if this density of the liquid is 0, if I again increase this quantity, it will not change the density, right? Thus density is an intensive property. So also if I talk about this temperature, say in this x quantity of liquid, if the temperature at normal conditions, say if the temperature is T, if I pour another x quantity of liquid, the temperature will not change because I am pouring it at the same temperature. So that means if I increase the amount of material, if it doesn't changes the property, then it is intensive. So that's why density is the answer. And mass is also changing, as I have told. Also the volume, say x, if I increase it, it will be 2x, that is the volume. Energy, whatever energy is carried by this amount of liquid, if I increase this amount of liquid to double, then this energy will definitely increase. So it is extensive. So the rest three are extensive property, only this density is intensive property. So it's a good response from you, Arjun and Dev. So density is the correct answer. So I think it is clear to you. I am moving to this next question. So what is this next question? The next question is that two statements are given. So you are asked to tell whether these statements are correct or wrong. Right? Either first statement is correct and second is wrong. Like that, these are the four options. So this is regarding this Reynolds Transport Theorem. Okay, I think in the class this concept, this is the first concept of this fluid dynamics part. So I think you have gone through this. So please try to answer this question. So I am giving you 1 minute time to try to answer. So Deb and Rini both have answered option A. Both are true. So Arjun, please try to answer. So Arjun is also saying A. Yes, it's the correct answer. So let me recap this concept for you. So first is this system. The two word is given here. One is the system approach. Next is the control volume approach. Right. So what basically is this system approach? And what is this control volume approach? So I represent this control volume as CV. So this system approach means in this approach we follow the same set of fluid particle over time. So what we do, we follow same set of fluid particle over time. So I am giving you an example in real life. Say in a river, a leaf or anything is flowing. A bottle is flowing over a river. So if you are following this bottle with time, so then this thing is called this system approach. That means whatever this system, this bottle you are watching. So that's why it is known as a system approach. Whereas in control volume approach, you only focus on a specific area. Say in this specific area you are observing. So what will happen at a specific time, this bottle will passes through this specific region. This approach is known as control volume approach. Okay. So this CVM approach is also known as Eulerian approach, whereas this system approach is also known as Lagrangian approach. So if I talk about this real life example, so you always remember such types of example. In the first cases, in a river, a bottle or a leaf is flowing. So you are following this leaf or the bottle. In this CB approach, you are only focusing on a specific region. You are observing whatever is going through this region, not the specific object. So that's why in this Reynolds Transport Theorem, what it did, it follows both this approach. That means it is also following a certain portion, this portion it is also following, and also it is following these sets of the fluid particle. It is so it follows both these things. And the statement B is a control volume focused on a region of space. That means this thing I have talked about. So that's why the correct option is option A. So all of you have answered it correctly. Okay, so I am moving to this next question. Any confusion on this concept? So please tell if you have any confusion, let me know, or else I'll move to the next one. Can I move to the next question? I think I can move. Yes, I'm moving to this next question. In this next question, so another two statements are given and you have to identify which of them are correct or both of them are correct. So you have to check. So I think as this concept I have told in the previous slide, now you can answer it easily. So please try to answer. I am giving you 1 minute time. So Harini is responding with option A. Let's see what others are answering. So they have answered option C. Arjun is saying option A. So see, it's good that you are answering. So let me clarify this thing. So first statement, in the first statement, it is given a control volume focuses on a set of fluid particle. No, actually a control volume in the, as I have told in the previous slide, it focuses on a specific area. Whatever particle is flowing, it doesn't matter. It only focuses on this region. So it's a control volume mainly focuses on a specific region in a space, not a set of fluid particle. Which concept will deal with this? This in the previous slide we have studied about this system approach. So this system approach deals with a set of fluid particle. So that's why the statement A is wrong. So next is this: a control volume can be fixed, movable or deformable. So see, so if I talk about this control volume, so what will happen? Whatever inside this particle it can move. It can be also happen that if a particle is there, it is fixed, it will not move. That can be possible. Or it can happen that this control volume can be, say I am talking about a car. So this is a car. This is a control volume. Okay. So I am representing this is a control volume. So what will happen if it is a rest? It is fixed. It can move. Okay. So if this wind is flowing, what may happen? A high velocity wind is flowing. Maybe it happens that it can break its what can side windows. There is a chance. So that's why a control volume can be fixed, movable or deformable. So option B is correct. So A is wrong, B is correct. So option C is the correct answer. So I think both of you have understood this mistake, what you have done. Is it okay? Yeah, okay. So I am moving to this next one. Yes, this next question is a basic question. So what this question states, the continuity equation is based on the principle of either energy or momentum, mass and force. Which one? So please try to answer. Yes, one have answered option B momentum and another as option C mass. So and that is energy. So three different answer I have got. So okay. Uh, Okay, so what this continuity equation is? Continuity equation is simply this mathematical form of this conservation of mass. So this continuity equation is the mathematical form of this conservation of mass. So what this law states, so you have studied it in class 11, 12 that mass can neither be created nor destroyed. So that concept is been given here. So whatever in a body, say this is a body. So this is the inlet, this is the outlet. So what this law states, say whatever is entering this through this inlet and whatever is coming out through this inlet, that should be balanced. Say if I am talk about if a certain particle, say m1 is entering into the system and m2 is coming out through the system. So that means m1 minus m2, that means a certain volume is there that is stored here. Okay, so that is the thing that is told in this theorem, that if m1 is entering into the system and m2 is coming out of the system, then there must be something that is kept here. Say I talk about this capital M, that means if m1 is entering, so what is coming out, m2 is coming out plus m, because total entering uh, through this inlet is m1 and only m2 is coming out and few portion is left out in the system, that is plus m. So that is the fundamental concept. And if say if it is an incompressible fluid, in case of incompressible fluid, so what will happen? So I am erasing this thing and writing this thing again for you. Just a minute. Hmm. So for any system you have studied about this thing. Say for a compressible incompressible system, that means whatever is entering into this system and whatever is coming out in this system, for an ideal case, forget about this incompressible, for an ideal case what will happen, if q1 is entering into the system and q2 is coming out of the system, then q1 equal to q2, that means nothing is stored or nothing is accumulated into this system. So that q is means, okay, so that q is the mass flow rate. Okay, so that is the concept of this conservation of mass. So more details about this concept I will discuss in this upcoming slide. So I think now you have got this correct answer and what this law states. So just remember that it basically says mass cannot be created or destroyed within a closed system. It has to be there. Okay. So can I move to the next one? Yes, Harini said, but sir, for any extensive property, energy, mass, and momentum can be described. Uh, So, whatever you are saying, that is, it is interrelated to each other. But this continuity principle means this conservation of mass. Whatever you were saying, that is interrelated. That means without solving one thing, you can't go for this other one. Say for this mass equation, if you solve this mass equation, so you will get certain parameter, right? So that parameter you can use in this energy equation or momentum equation. Any confusion? Okay. So Joyram, any confusion from your side? So I am moving to the next one. This is regarding a numerical question. So, so, so Jairam, can you please turn off your mic? So, see, in this question, what is given? The water enters a nozzle with a given velocity is given, right? This is the inlet velocity and this is the outlet velocity. So, mass flow rate of water is also given. So, you are asked to find out this force exerted by water on this nozzle. So, that's a simple question. So, please try to solve. I am giving you 2 minute times to solve this question, and if you are able to solve this question, then please answer in the chat box, or you can also turn on your mic and answer this one. So Rini has answered option B, that is 100 Newton. So let's see what other are answering. So शुभजीत, रिकॉर्डिंग हो रहा है, आवाज आ रहा है, रिकॉर्डिंग हो रहा है, রেকর্ডিং হচ্ছে। So I am solving this thing for you. So Nihalini has answered. So see, from this conservation of momentum equation, So see, in the last slide I have discussed about two things. One is the conservation of mass, then is the conservation of momentum. So before, just a minute. So I am just confirming this thing. This thing what I have talked about, this is about this conservation of momentum. And the previous one that I have discussed is about this conservation of mass. So what this momentum equals to, so if anything, any flow rate, whatever flow rate is entering a system, it should come out with the same flow rate. I am talking about this mass flow rate, not mass. If it is mass, then this is the conservation of mass, but in the momentum, it should be the momentum carried by this mass, that is q1, and this should be q2. Okay, so here they are talking about this force. So what basically force is? So force basically means this mass flow rate. So whatever the mass is entering this system into outlet velocity minus inlet velocity, right? So this m dot basically means is 10 here, and V outlet is 15, V in is 5. So that is 10 into 10. So the correct answer is 100. So 100 Newton is the correct answer. So your answer is correct. So I think that you have understand this thing. So please rectify this thing that I have discussed in the earlier session. Most probably I have talked about in the I have most probably in the earlier slide this thing I have told about this conservation of mass by mistake. It's a conservation of momentum. So I am moving to this next thing. So this is the next question. So in the first 5 questions, the level of the question was quite easy, and as we move to the upcoming question, the level will slightly increase. So you better use your concept, that will help you to clarify all these things. So the first is there, what is given? Consider a steady and incompressible flow through a converging nozzle. So cross section area is given from the for the inlet and outlet, and also the velocity of the inlet is given. So you are asked to find out this velocity of the outlet. So what I have told in the earlier slide, which concept is linked with this velocity and mass? That is the conservation of momentum, right? In the momentum you have studied about this momentum. What basically is momentum? Mass into velocity. So basically as this velocity is given, that means indirectly this definitely this conservation of momentums will come into play. If mass is given, say for a certain question, if the mass is given, you first think about this conservation of mass, and after that you think about this conservation of momentum. So please try to solve this question. I am giving you 2 minutes to solve this one. So Rani said option B. So Joyram, you please try to answer. So please try to answer. So two people has answered option B. So let me solve this one. So say for an so for any steady flow, okay. So what this equation basically state. So that m dot means mass flow rate, okay. So if I talk about this continuity equation, what I have said, whatever is entering the system that should come out. So I means inlet and this one means outlet, O means outlet. So whatever entering this inlet and whatever coming out, this should be same. So what is mass? Say this one is m1 and this one is m2. M dot. Dot represent mass flow rate, that is change in the mass per unit time. So that is equal to rho A V. That is the formula, right? So what is entering here? Say a liquid is entering that has a certain density, say rho 1, area of this section say A1, and velocity be V1 equal to rho outlet, area at the outlet, V at the outlet. Why I have taken this thing? Say if this types of nozzle is there, if say this one is V1, for a specific case I am talking about, this two is V2, okay, this one is A1, this one is A2. That means say this area is small, this area is larger, okay. So that's why area can be different and velocity also is also different. And sometimes if the flow is not incompressible, some flow is compressible, in that case the density should be different. So that is basically this continuity, basic principle of this continuity equation is there. If it is incompressible, in case of incompressible, what is there? This density should always remain fixed. That means rho 1, rho 0 should equal to be a specific value. Say consider it is a 0. Then these two will cancel out. So what I will get? A1 V1 equal to A2 V2. So in this question what is given? So the inlet velocity is A1. That means in this question it is given area is more at inlet and area is small as outlet. That means they are talking about these types of nozzle, that is a converging nozzle, okay. So here the velocity is V1 V2. So what we are asked to find? We are asked to find V2. So V2 equal to A1 by A2 into V2. That's why option B is the correct answer. So it's great that you are answering. So I think it is clear to all of you. Say now just a question for all of you. Say in this question area of one. So this, just a minute. In this question it is given A1 is greater than A2. Can you tell whether V1 is greater or V2 is greater? Question can be asked. So please try to answer this. Which one is greater? Whether V1 will be greater or V2 will be greater. So Arjun, Harini, Dev, Jairam, anyone? Please try. So Harini's answer B2 will be greater. That is correct. Why? See, if A2 is greater, definitely here A2 is greater. A2 by A1 by A2. Since A1 is greater and A2 is smaller, then if I divide both these two, then this value will be greater than 1. Okay. So that's why V2 will be greater than V1. So I'm moving to the next one. So our correct answer is option B. So this is a theoretical question about this Reynolds Transport Theorem. So the question is, which terms in this Reynolds Transport equation represent the net flux of a quantity across the control surface? Local derivative term, convective term, source term and dissipation term. Which one would be the answer? So please try to answer. So Rene's answer convective term. Okay. No, not convective. Option D. So that means you are telling that dissipation term. So they have answered option A, local derivative term. So let's see the answer. So as you have gone through these classes, so first let me write this equation for you. That means this Reynolds transport theory, or it is more specifically known as RTT equation. So what this equation term? So I am writing it in generalized form. That means you can write this equation for mass, momentum and energy, all this equation. So say any term or any property, it may be mass, it may be velocity, temperature, any property, I represent it as B. So that is B of system I represent. So what is this equation tell? The derivative of this is dV by dt, that means rate of change. If the derivative in the derivative denominator there is t, that means that is whatever is the change of this parameter with respect to time. This thing is indicated here. Next is CV, density into a term beta. So I am explaining all this term for you. First let me write down this equation. Cs rho beta v dash and dA. So this equation seems to be complex for you if you are in BTech. But if you are studying, if you want to go for this higher studies, you will find certain types of equation. So in these classes, each significance of each and everything has been taught. I am just recapping this thing. So what I have told that what is beta? B means property, any proper. And what is beta? Beta is the corresponding intensive property. So you know intensive property and extensive property, right? So this say I am talking, if I talk about this B. So if B is, for example, I am talking about this B, say momentum. So momentum is an extensive property. So basically it is an, here B represent an extensive property and beta represent corresponding intensive property. That means you have to convert this extensive property into intensive property. Say mass. If I talk about mass, right? If I convert it into intensive property, then it should be density, like that way. So up to this it is clear. So that is the thing. If I divide mass by volume, that means if two extensive property I divide one extensive property by another, then I will get an intensive property. So that's why B and beta will come. So that is the thing. So I am now explaining each term. First tell me up to this is whether it is clear or not. Okay, I think it is clear. So see this first term, what this first term indicate on the left hand side of the, in this left hand side, so this left hand side term indicate the total rate of change of this extensive property. Okay, so that means it is the rate of change of this extensive property, and this is the left hand side term, rate of change of extensive property. Next is this term, what this term represent. So this is the local derivative term. This is known as local derivative term. What is the significance of this term? So it basically, what it measures a certain, say in a certain control volume. So it is a control volume. In a certain control volume, if B is there, B is an extensive property. Whatever may be the change of this extensive property inside a control volume at a given time, that information is being given by this term. Okay, the first term gives the information about whatever be the changes of this extensive property. Say in this, if some mass is flowing here and some mass is coming out, if something is storing inside it, then this is called this local derivative term. So that means the change of this accumulation inside this control volume, that information is been given here. And the second term is the, this one is the convective term, most important term. So what this term represent? This term represent what is the amount entering into the system and what is the amount coming out from the system. That means the net flux. So if the word flux is, you see this word flux, it basically in it basically indicate whatever is coming and whatever is going out of this system. So that means this second term on this right hand side is quite important, and it is the convective term which show whatever is entering into the system and whatever is coming out of this system, and this first term indicate whatever is accumulating in the system, right? So that is the thing. I think you understand this concept, is it? So please go through this concept, because if you are appearing for this NPTEL course exam, you can find such types of question. So they will not ask you to write this equation, but they will ask you basic concept like which term will help, which term will represent the accumulation inside a control volume. Then you can say this local derivative term. Okay, so that is the thing. So I am moving to this next question. So again, it's another question on this concept of RTT, Reynolds Transport Theorem. So what is the question? In this question, it is given in the context of RTT, which of the following statement is most appropriate? So that is the question here. So please try to answer. So that thing I think that I have discussed in the earlier slide. So you remember this system approach and the control volume approach. In this slide, I have talked about this thing. So please try to answer. C. Hmm. Option C. Yes. So both Hirni and Dev has answered option C. Okay, is the correct answer? Because already I have discussed in this earlier slide. So what is this concept there? In this concept, the concept was that for a system approach, it should include a set of particles, whereas for this control volume approach, it only deals with a moving or fixed space where this flow is studied, right? And this RTT concept incorporate both this system approach and this control volume approach together. That's why this concept is quite vital. So the correct option is option C. So option C is the correct option. So I am moving to this next question. So it's a quite interesting question, again from this RTT theorem. So as I have told you about this RTT concept in details about, and also the what are the parts of this equation, can you please answer this question? So please try. It's a tricky question, but it's the full equation that I have written. The left hand side, right hand side, two term I have written, the local term and this convective term. So René has answered option A. Okay, let's see what they is answering this one. D. Okay, say it's option D. Okay, and they have answered option C. So I think a confusion is there for them. Yes. So option D is the correct. That is true. So why? First, if I forgot about this equation, if you do not remember this equation, but you understand one thing that it incorporates two concepts. What are this concept? This is the system approach and this control volume approach, right? So in one side there should be system approach, in another side there should be control volume approach. So that is the instantaneous change of B inside this. So if I split it into two parts, if I split this statement into two parts, so up to this whatever is there, the instantaneous total change of B inside the, it can be control volume or control mass. So I will talk it about later, is equal to this instantaneous change of total change of B within dash plus net flow of B into and out of this. So in the, remember I talk about this thing. So here it is clear that here I am talking about this control volume, because whatever is coming into this control volume and whatever is coming out for this control volume, I am talking about this thing, right? And next is the first is the instantaneous change of B within. That means whatever is accumulating into this system, that is it's talking about CV. So in the right hand side talks about this right hand side. Right hand side is all about this control volume approach, and the left hand side is about this control mass approach. So that's why option D is the correct option. So see how this concept is quite important. If someone understands both this concept, that is the system approach and this control volume, then they can easily answer this question through this concept. So that have you understand the what are the mistake that you have done, or any confusion from your side? Okay. Mm. Another thing, I have talked about this B and beta. What is B? B is a extensive property and beta is the corresponding intrinsic property, right? So please remember this concept. So that can be, this thing is quite important. So based on this I am giving you one question, so please try to answer. So this is the question. So what is given? Momentum be one of the extensive property of the fluid, because it depends on mass, so it will definitely be an extensive property. So this momentum is represented by beta, it is given in this question. So you are asked to find out this corresponding intrinsic property of the fluid. So René said option B. So let us see what they are answering. They is saying that it is mass. So again, they is confusing himself with this concept. Just a minute. So see, as I have already told that B is my extensive property. So what is the basic difference between extensive and intrinsic property? So basic difference is this: intrinsic property is independent of the quantity of material in the system, matter in the system. So this one is my extensive given and beta is the intensive. So as beta is independent of the material of the system, that means here I have to derivative this beta with respect to mass. Okay, mass is the amount of material in the system. That's why I am you can say it is derivative, or someone can be directly divide b by m, that can be thing, but the feasible solution always can be the derivative with respect to the quantity of the material. It can be mass or it can be volume, right? So what beta is given in this question, it is the momentum. We know momentum is mass into velocity, right? So velocity is a constant here, so v will come out and derivative of this is 1, so there should be velocity. So that's why this correct answer is option B. So option B, velocity, is the correct answer. See, this RTT concept is quite important. So I will again suggest you that, so please go through this concept clearly and try to understand each and every term precisely, because it's not for this exam, and if you are in BTech, then it is quite important for you, because you have to do your project on all these things, maybe on heat transfer or fluid mechanics. Maybe it is quite essential for you. Even in terms of interview or placement, they can ask you basic question. Not, they will not ask you to write this equation, they will ask you how, what is the significance of this equation, like that. Okay, so you both are in. So any confusion, Rini or Dev? Hmm. So you are in BTech or MTech? You both? Okay, so you are in BTech. So that's great. So you will got to understand a lot of things. So that's why whenever you are learning a course like fluid mechanics, which is an interdisciplinary course, for even for mechanical students, they are also learning these courses. So please try to correlate each and every concept with real life scenarios. Like one of the important is the Lagrangian approach and the Eulerian approach. So if someone asked you what is the difference between this Lagrangian approach and this Eulerian approach, so it is nothing. This Lagrangian approach is this system approach, or this Eulerian approach is the control volume approach. So if someone is not from this engineering department, if someone is from say basic science or from arts or commerce student, they will not understand this concept. But if someone asks you this thing, how you will tell them? You can tell them with a real life example. Say I am giving you an example of a bottle or a leaf flowing over a river. So if you are focusing on this bottle, then it's a Lagrangian concept, right? So the what seems to be complicated, but the concept is quite easy. And if you focus only on a specific region in the river, then it's the Eulerian approach. So it depends on it depends on your application, what you are targeting, whether you are targeting the bottle or whether you are targeting the specific area of the river. So that is important in this study or in this concept of fluid dynamics. So let us move to this next question. So this is the this is our 11th question. So it's a numerical question. What is given here? So a figure is given. So I think this figure is clear to you. In this figure, the diameter of the inlet pipe. So that pipe D1 is given, and also D2, that is the outlet one, is given. So and again another pipe from the above is used to pour water into this tank. So velocity of the inlet pipe is given. So also the flow is assumed to be steady and compressible. The velocity of flow at the outlet will be. So you are asked to find out the velocity of the flow at the outlet. That means you are asked to find out V2. So please try to understand. So see, this is another conservation equation. So I am giving you 2 minutes to solve this one. So please try. So this is option B, 3.87. Okay, let's see. So let's see what they are answering. So they will answered option C. So let's see what will be the answer. So see, first we have studied till now. We have studied about two things. One is the conservation of momentum, and another is the conservation of mass. Conservation of mass. What this equation states? Basically, this equation states summation of mass inlet should be equal to summation of mass outlet, right? So why I am talking about it, because it's a steady system, so that means I can assume that nothing is accumulating in the system. If x amount is entering, then a total of x amount, if total of x amount is entering into the system, then total of x amount should be removing out of this system. That is the conservation of mass. And the conservation of momentum, what this equation is? This equation is F total force acting on this system equal to mass flow rate into outlet velocity minus inlet velocity, right? We have studied about this thing. So see, if in a question, what I have said, if mass is given, say mass or velocity, anything is given, and what is given here, this velocity, flow rate means this, talking about this thing, this is given. So if these two thing, any of these two thing is given, so you first try to solve this question with this conservation of mass equation, and again after solving this thing, if you are not able to get this answer, then you go for this conservation of momentum equation, right? This should be the concept for each and every problem like this. So first, for this question I am applying this mass conservation equation. Mass conservation. So I am talking about this mass inlet equal to mass outlet. So what is mass inlet? So from 1 mass is entering into the system, and from 3 mass is entering into the system, and mass is coming out from the system, that means outlet is M2. So in place of summation of Mi, I can write M1 dot plus M3 dot equal to M2 dot, yes, okay. So I have to find out this value of M1, M2 and M3. Say if I talk about this M1, so what I know, mass, generally formula of A is rho AB, or I can write rho Q or rho AB. That means Q means AB. Okay, Q is the mass flow rate. Okay, so here I am talking about this one. So whether density is given, density of water, since in this case, in this problem, everything is water. right? So in case of M1, I write rho. I am not putting the value of rho because rho is common in all these three density. So Q3 is Q, the diameter is given. So I have to apply this formula area. What should be the area? Area equal to pi by 4 into d square. What is the diameter here? Diameter is 5 centimeter. That means 0.05 square into velocity. Velocity, whether the velocity is given, yes, is 2.2 into 2.2. That is the, it is given in this question. So in place of m1 dot I can write pi by 4 into 0.05 square into 2.2. So I got this m1, right? So m2, in the m2 q3 is given. Sorry, m3, I am talking about this m3. m3 equal to q is given, so I can write it as rho into q3. So what is q3? q3 is 0.01. Check the unit, it is in meters cube, so I can write it as rho into 0.01. Now I have to find out m2. So in m2 again diameter is given. So similar to m1 I can find m2 equal to rho AB. What is area? Pi by 4. Diameter is 7. So 0.07 square into 3.2. So I can write rho pi by 4 into 0.07 square into V2. See, here I can cancel out rho from all sides because rho is common. So you have to find out V2. So you have to calculate this value plus this value and divide it by this remaining. You will get V2. So please calculate and tell me the answer. So Rini and Dev, both please both of you check this calculation, because whatever answer I have got here is option C, that is 3.72. Check whether it is coming or not. Is it coming? So please let me know whether it is coming or not. So So the correct answer is option C, 3.72. So accordingly you can find this V2. Okay. So I am moving to this next question. So in this question, what is given? A cylindrical tank of radius 1 meter is filled with water up to a height of 2 meter. So another thing that is given in this question, water is being pumped into this tank at a rate of 0.1 meter cube per second. So Q is given. So you are asked to find out, calculate the rate of change of mass of water in the tank. So these are the four options. So this is the similar types of question that I have discussed in the earlier one. So please try to answer. So I am giving you 1 minute time to answer this one. Hmm. So there, please try to answer this one. So this is similar to what I have discussed in this earlier question. So they have answered option A. So what is given in this question, that a cylindrical tank is there in which the radius of the tank is given, and also the height of this height of the water is given. So water is pumped into this tank, so that means this mass flow rate that is entering into this tank, that it is also given. So you are asked to calculate the rate of change of mass of the water in the tank. That means whatever is accumulating in the water, that should be calculated. Okay. So Biplab, can you try, or I will solve it for you? Okay. So I am solving this thing. So please have a look. Again, this similar concept is here. Say this is the tank. Okay. In this tank, so up to this water is already there. It is given 2 meter height, and all this thing is given. And say from somewhere, say here from there, Q is coming as 0.1. That means this is the inlet, mass flow rate in the inlet. So you are asked to find what is the rate of the change of the mass in the water. So in this question, whether it is given, whether some amount of water is coming out of the system or not, nothing is given. That means whatever is pouring into the system, it is storing here. So, and also it is not say that it is a steady flow or anything. It is not given steady system. So from this conservation of mass equation, what I have, So they are asked to find the rate of the change of mass of water. So that means dmdt. So what does dmdt indicate? Dmdt indicate that is what is the change. Say initially this much of volume is there. After pouring there is this much of change in the volume. So that dmdt is referring to this change, right? So how we'll find out this change? To find out this change, you have to know whatever is the total inlet mass entering into the inlet and mass coming out of this outlet. Okay. So if it is in a steady state, then dmdt this one should be 0 because nothing will accumulate in this system. So whatever is entering the system and whatever is coming out of the system, they should be equal. But here there is no such thing mentioned. It is in the question. It is already given that the change of the mass, rate of change of mass of water in the tank. That means it is already accumulating. So I talk about this first term. So what is entering this inlet? This Q1. So I know this M1 equal to either rho Q or rho AB, right? So since Q is given, so I have to use this formula. So M1 dot equal to rho into 0.1. So rho of water we know it's 1000, but I am not putting it here initially. So no, okay, let us put this value because already it is given here. So that means it is 1000 into zero point 0.1. That means 100 kg per second. This is M1 dot. This is this M1 dot mean indicate this Mi because in the inlet only through one area this mass is entering. So instead of this one I can write M1 dot, nothing is there, and outlet, whether there is any outlet, no outlet is there, right? As no outlet is there, that means I can say this term is 0. So what is M1 dot? M1 dot is 100 kg per second. Okay. So option A is the correct answer. Is it clear to you? Is it clear to you, Biplov and Dev? So if you have any question, you can ask me, or I will move it to the next one, to the next slide. Kindly let me know. So I think it is clear to you, Biplov. So I am moving to the next one. Yes. Another important thing is that whatever the question I am solving here, I will share it with you after this class. So you will get a mail from this NPTEL and every week about this feedback. Along with this feedback, you will find this link to this PDF. So if you also find any types of problem regarding this, you can also raise this concern through my mail ID, which has already been shared with you. So this is another question. So in this question, what is given here? So a cylindrical tank with a diameter of 2 meter is being filled with water from a pipe with a flow rate of 0.1 meter cube per second. That means a tank is there where water is pouring with a pipe and the flow rate is given, that is Q is given. So how long will it take to fill the tank to a height of 3 meter? So to fill this 3 meter, how much time it is required? So that's a simple question. So please try to answer. So I am giving you 2 minute time to answer this one. So please try to answer. So similar concept you can. So the thing is that for 3 meter, the concept should be like for 3 meter, how much volume is required, and in and the mass flow rate is also given. So accordingly, you can find out this time. So I am giving you a hint. So whatever be the volume fill, that should be equal to this mass flow rate into time, right? So this is the concept that a volume equal to Q into T. So you can use this formula to find out this answer. So please try. So anyone? So Biplab, Dev, anyone will be able to answer this one? Okay. Dev is saying that option C will be the answer. So let us check. And Biplab, anything from your side? So see, so what basically is given here? In this question, the diameter of the tank is given and say that it is filled with this. So say this is our tank, right? So in the question, diameter is given as 2 meter. This height h is given as 3 meter. Okay. So up to this height we have to fill and through a pipe. So here Q is given, Q is 0.1. So if I have first I am calculating this volume. So volume here is pi r square h. So that means pi. What is r? Diameter is 2, so r should be 1 meter. So 1 square, and height is given as 3. So I can write it as 3 pi. Okay. So q is given. So I have to ask to find how long. That means the time it takes to fill the tank. So time it takes to fill the tank. So if I replace, that means say the unit of q is 0.1 meter cube per second. That means the volume per second. So if I multiply this q into t, what will I get? Q into t. This one is equal to this volume, right? Oh, therefore I can write T equal to V volume by Q. So volume is 3 pi and Q is given as 0.1. So now calculate pi is 3.14. So 3 into 3.14 divided by 0.1. Please calculate. So if you calculate, you will get the answer as 94.25 seconds. So that is the answer. So is it clear to both of you? So it's a simple question. So I am moving to this next one for you. So this is the penultimate question, and after this we have another one question. So in this question, what is mentioned? The water flows at a uniform velocity of 3 meter per second. That means velocity is given into this nozzle. That would reduce the diameter from 100 mm to 20 mm. Calculate the water velocity leaving in the nozzle and coming out of this nozzle. So that is the question here. So I am just drawing this diagram for your better understanding. So in this question, say that a nozzle is there. So here diameter A1, sorry, area A1, A2, and say this velocity is V1, this one is V2. So given diameter is 100 mm, here diameter is 20 mm. Okay. So you are asked to find V2 because already V1 is given as 3 meter per second. So you can use, it's a quite is this concept that you can use this continuity equation. So please try. I am giving you 2 minutes to solve this one also. So see, similar types of question I have discussed in this earlier slide. So try to utilize this continuity equation and you will be able to solve this one. So any one of you? So Dev, Biplab, anyone? So Dev has answered option A will be the answer. So I will be waiting 1 more minute for Biplab to try. So I am solving this one for you. So please have a look. So as I have mentioned in the earlier slide, so if in any question this velocity or mass flow rate it is given, so you first think of this continuity equation initially, that is the conservation of mass equation, and after that go for this momentum equation. So what this continuity equation state, or the mass conservation equation? So I am talking about this mass conservation equation. So see, it is water is given, right? And anything is given, no. In a nozzle, we know there is a steady flow, so nothing accumulation. In this question, there is no talk about this accumulation or anything. So I can know that whatever the mass flowing enter into the system and the mass the coming out of the system, that should be remain same because nothing is accumulating in this system, right? So in the inlet area, velocity, and all this thing is given. So I can write it as rho A1 V1 equal to rho A2 V2, because at the outlet, the mass of outlet should be mass flow rate rho A2 V2. So since this is water, so density at inlet and outlet should be equal. So I can cancel this to 1. So I will get A1 V1 equal to A2 V2. So, so it is in the question it is asked to find V2 because velocity leaving this nozzle, that means V2. V2 is A1 by A2 into V1. V1 is already given as 3. So A1, what is A1? This diameter is given, so I can write as 4 by pi by 4 into D1 square. So similarly A2 equal to pi by 4 into D2 square. So this is pi by 4 into D1 means it is in mm, 100 mm. So I have to convert it into meter, that is by 1000. So that is the area, and here it will be pi by 4 into 20 means 0.02 square. So in place of pi by 2 and pi by 2 will divide each out. So A1, instead of A1 I can write 0.1 square by, in place of 2 I can write 0.02 square into velocity 1 is 3. So dividing all these things we will get 75 meter per second is the answer. So that means option B and option D is cancelled out. So we have two options, option A and C. So next is that also they are asked to find out this flow rate. What is flow rate? Huh. So what is this flow rate? This flow rate basically is the Q. So I know Q2 they are asked to find out Q. So, and another thing I know that whatever be the value of Q1 and Q2 that should be same because mass inlet and outlet will show. So I can write Q means A1 B1. If someone want they can also calculate using A2 B2. So A1 is this one. You will got some value here and B1 is 3. So you just put down this value here or you can put down this value also B2 and A2. So the answer that you will get is 0.0236 meter cube per second. So that's why this option A is the correct option here. Okay, that is the solution here. So this is a simple question. So I am moving to the last question of this session. So this is the last question for today, and I think that as you have gone through this concept, you can easily able to answer this one. So a figure is given where there is an inlet which is represented as 1. So this one is the inlet and 2 outlet is there. So what is been given, what is asked to calculate, it is asked to find out this rate of change of mass of water in the device. That means something is accumulating in this system. So this mass flow rate entering the system and mass flow rate coming out, there should not be equal. Something is accumulating in this system. So please try to calculate. Deb and Biplab, please try to calculate. This is the last question for today. So I am giving you 1 minute time to solve this one. So again, this in this question you have to apply this principle of conservation of mass. Where the formula should be, I am just giving you a hint. That is the rate of the change of mass to this, or the accumulation inside the system should be equal to mass entering the system minus mass coming out of this system. So that is the scenario for this question. So anyone? Anyone? So I think no one. Okay, Dave has answered option C. Yes, option C is the correct answer. So any response from Biplab, or else I'll start to solve this one. So, okay, let me solve this one. So again, using the same concept, that is the mass conservation. So this mass conservation RTT theorem is quite essential for this chapter, or and another thing is this conservation of momentum. So please have a look into this thing carefully, because you will definitely find some important question. So what I say, something, if something is accumulating in this system, if I represent it as dm by dt, it should be mass inlet, total of the mass inlet in the system minus total of the mass outlet in this system. Say, what is the mass inlet for this system? This m1 dot, say only one inlet is there, so I can write it in m1. And for mass outlet, there is two things, m2 and this one. If it is 3, that is m2 dot plus m3 dot, that is the mass outlet. So in place of summation of mi, I can write m1, because only one inlet is there and two outlet is there, so I can write it as m2 dot plus m3 dot, right? Okay, so I have to find out this value of m1. So velocity is given, so I can write m1 dot equal to rho a1 v1. So rho I know it is 1000, area diameter is given 8 centimeter, so I can find the area pi by 4 into diameter, that is 0.08 square into velocity, that is 10 given here. So you just calculate this thing, you will get a value. So I am just calculating it for you. So what I have got, it is as 50.3 kg per second. So in place of m1 I can put as 50.3, right? So m2 is already given as 4, so no need to calculate m2, but I have to calculate m3 dot. So for m3 dot, q is given. If what is q? Q means a into v. Area and velocity is not given, but q is given. So I can write in place of a and v, I can write it as q3. So that is 1000 into 0.008. That means it should be 8 kg per second. So I can put 8 here. So that means 50.3 minus 12, which is 38.3 kg per second. So option C is the correct answer. And Dave has answered this correctly. Today Dave has answered most of the answer correctly, and also Harini has answered. So any confusion from your side up to this? Because this was the last question that has been solved for the today's session, live session. If any confusion for this session, please let me know, or else I will wind up this session. So any confusion, anyone? So no confusion. Okay. And thank you there for responding to this. And so I can end up this one for today. So if you feel any confusion regarding this, you can contact me through my mail ID, which has already been provided earlier. So and another thing is that you can find out this link to this slide, which will be shared from this NPTEL site to this feedback form. Along with this feedback form, you can go through this, also the recording of this session, previous session. If you missed the previous session, you can find out this video in my YouTube, where this has been already uploaded. So till here, have a good day and bye, and thank you everyone. So, so you can leave. So thank you everyone.